Hello, Rob. Thank you very much for accepting our invitation. It's an honor for me to have you here in our podcast. First of all, may I kindly request you to briefly introduce yourself and provide us with some information about your background and experience, especially in the field of proficiency testing, laboratory accreditation, and similar areas. Thank you very much.
Okay, thank you for inviting me. Well, after my chemistry study, I started as a teacher in high school, and after 6 years, I started to work with inspection company SDS, worldwide company, and there I set up a new environmental laboratory. There were not any at that time, and together with the environmental laboratory, and the quality system was needed. So we started the quality system and got an accreditation for that ISO 17025 quality system. Later on, someone else became manager of the laboratory, and I worked as quality manager of all the laboratories in STS Netherlands. Later on, I started IIS, the Institute for Interlaboratory Studies, which organized PT, in principle, in the beginning for SDS laboratories only, but after a few years, we opened it for non-STS laboratories. And that IIS was also accredited for ISO 17043. That was a new accreditation. Also, the Dutch accreditation board did not have any experience with that standard. So, well, in short, that's my experience.
Okay, thank you very much for the introduction. As we have already talked, today we are going to talk about the quality assurance of test results. And my first question is that as it has been mentioned in ISO 17025, laboratories need to plan their activities required for ensuring the validity of their results. And in planning such activities, several factors should be considered, such as the number of samples they receive for a certain test or other factors that are important. Could you please let me know what factors need to be considered when planning for these QA activities in a laboratory?
Well, there is a difference between planning for a new test and planning for a test that the laboratory already performs. For a new test, you have to check and to plan whether there is a standard method available, standard test methods, whether you have the necessary equipment, whether you have necessary personnel with a good education or good experience for that method. Then, of course, do you have the chemicals? Do you have the consumables? Is there a certified reference material available for that method? Is there a relevant PT available for that method? How can you set up relevant and good quality control for the test method? With the means available, how can a test be evaluated, validated? And finally, are the costs to be made for all these points acceptable to the management and to the customer? That's for a new test. When you have already a test running, things are a bit different. You get test results, and you have to check those test results against some values. There may be a specification from the customer or from a regulation. It may be you have to check replicates against repeatability. Of course, you have to appoint a person responsible for all those checks. And then there are standard things like are the quality control results okay? Control charts are no strange things. Is the maintenance done properly? Have you participated in a PT recently? All those kind of standard things.
Okay. Continuing this from this point, in the new version of the latest version of ISO 17025, there is a focus on risk-based approach in every aspect of the laboratory job. How we should apply this risk-based approach in planning QA, QC activities. For example, I was reading a document in which it said that, okay, based on the number of previous failures in internal quality control, you may change the interval for participation in PTs or similar criteria. I would like to have your idea about how this risk-based approach should be considered when planning these activities.
Yes, I think it's correct what you say. You have to do a quality a risk assessment for each test and for each process in the laboratory. And when some step or some parts have a high risk, you have to do more QC than for a step with low risk. For example, when a balances, modern balances are very stable, and you hardly have to do anything with them. The only thing you have to do is do a small check with some weight, nothing more. So calibration is almost never needed. So the frequency of checks, calibration, and other quality things about the balance is low frequent, and not very intense. But for other steps, in the laboratory, there may be a higher risk, and in that case, you have to implement more QC at a higher frequency, just to avoid that a high-risk step will disturb your test results. So that's fully correct. When you have an easy test, PT participation, for example, could be low, once a year, once every 2 years. But for a high-risk analysis, it may be that you have to participate twice or thrice a year in the PT. Yes.
Okay, thank you very much. Based on your response, can we say that quality assurance plan is a dynamic document which is subjected to changes depending on the turnover of human resources in the laboratory, changes in the number of incoming samples, or some lockdown times such as the pandemic, or changes in equipment, reagents, and other factors? I mean that we should be ready to change it based on the changes in the environment that we are working. Am I right?
Yeah, in principle, you're correct. It may also be a new customer with new requirements that causes you to start a new risk assessment. But the changes should be low frequent, so you cannot change something every week or every month. Changes should be at a low frequency, so once a year, maybe no problem. Because when you change something, it may mean that all your historical data will no longer be valid. And you have to start all over again building up those historical data. And you want to avoid it. So don't change things too quickly. Think about it very carefully.
You mean that if there is a change in staff or equipment, we should wait a little bit to see if this change has an effect on our historical trends, and then decide about changing the frequency of QC.
Maybe so. When the change is relevant, you have to check it. But small changes, of course, are no problem. It's also part of the risk assessment. When you make a change, you also have to make a risk assessment to estimate the effect of that change. When the effect is small, well, it's easy, you can do it. And when the change is large, well, you have to perhaps revalidate something. You have to build again your historical data. Yes.
Okay. My next question is about a certain requirement in ISO 17025 class 77 in which it asks the laboratories to identify the trends in their QA or QC results. I was once in a training, and the trainer said that you need to have control charts for everything. Changes in the slope of the calibration curve of your instrument should be on a control chart so you can see the trends, or even your repeatability or your QC material results. I would like to have your comments about why this trend checking is so important for the labs and how they can monitor such trends.
Well, there may be a misunderstanding. Trend does not mean that you have to have a quality chart. First, about what you said about the quality chart, you have to have that author said you have to have one for each step. Well, I disagree. I think your risk assessment, from your risk assessment, you have to take out the steps, the high risk steps, and those steps, there you should have a quality chart. It's rather useless to make a quality chart for a low risk step and that the value on the quality chart is always correct. Then it's work for nothing. It doesn't say anything. You know already it should be all right, and it is all right. Of course it is all right. It's a low risk step. So avoid that. Don't do that. But the choices you make have to be the high risk ones, and they have to be sensitive and specific. So when the quality chart says something is wrong, you know almost immediately what is wrong, because there was a specific reason why you took that quality chart. Yes? Then the trends. You may see a trend in quality charts, but when the trend is small, you won't see it. So there is a specific rule you should add, or you could add to the quality charts to observe low trends. For example, a quality chart usually has 30 points, 30 days or 60 days, that time scale. But the drift of analysis, the trend of analysis, the drift of analysis could take months, years. So you won't see it in one chart. You only can see it when you compare chart of, say, last month with the chart of last year, a year ago. Then you may see a trend. And I think that is what's meant in ISO 17025. So a long, slowly drifting trend that you don't see in one chart.
Okay, and is there any tool that we can, a statistical tool, I mean?
Mathematical tools, you can, it's like when you have, when the chart is full, you have to compare the last 30 data with the previous data by the two statistical tests, the t-test and the f-test. And same you can do with the drift. There is some constant you have to divide by another constant, and you see when it's larger than that, then you have a drift, a trend, significant trend. Yes.
Okay. My next question is, let's stick to this control chart issue. Is about in most of the laboratories they use ±2 or ±3 times the standard deviation as the control limits in the control charts, and these standard deviations come from laboratory historical data, and they set a criteria for the future activities. But some people believe that we should use some prescribed or target standard deviations, not the laboratory's own performance criteria, in order to check if you are in a correct position or not, if you are doing your job correctly or not. What is your idea about this prescribed target values versus historical standard deviations?
Well, both methods may be correct, or maybe the best to choose, because you can choose which one you want to take. It's depending on the type of tests that the laboratory performs. For example, an environmental laboratory will almost always use the statistical 2 and 3S limits. This because there are no other fixed limits to evaluate against. Also, the samples don't allow that. Often those samples are homemade or are not reference materials. But for other laboratories, we do have other limits. For example, petrochemical laboratories, they usually work against ASTM standards, and almost all ASTM standards report repeatability and reproducibility. And in that case, you can easily use those fixed figures for your control charts. You don't have to use 2 and 3S at all. And when you do use those fixed limits derived from repeatability and reproducibility, you will automatically know with each point at control chart whether your method is in agreement with the standardized ASTM method. Mm-hmm. So you don't have to check that separately. So in that case, it's a win-win situation to do that.
You mean that it depends on the information that are available for you, and if there are some information about the performance of a method, you may use that. Otherwise, you need to provide your own performance criteria.
Yes, it may also be a client that has some requirements. For example, in the Netherlands, we have many water regulations, and in those legal water regulations, the government has set limits. So when you use those limits, you automatically know that you're in agreement with the law. So that's easy, it's handy. So most of those laboratories will use those fixed limits and don't use 2 and 3S.
Okay. My next question is about inter-laboratory comparisons. In some areas, laboratories need to organize inter-laboratory comparisons of their own because no appropriate PT is available, or PTs are too expensive for some labs, or so there are some transportation issues you are familiar with for dangerous goods or other similar items. And they design and organize their own inter-laboratory comparison with a small number of participants. And based on my experience, I observed that in some cases they are not so effective. The variation between the labs are too high. There is no fixed assigned value, and statistically the number are too low. What is your idea that sometimes it's better not to have any external quality control in such situations, and it's better to put your focus on inter-laboratory comparison and have a well-organized inter-laboratory comparison in order to accept the risk of incorrect performance signal in an external quality control based on a small number of inter-laboratory comparisons? May I have your comments about this?
Yeah, this is difficult, really a problem, because of course you're right. The more participants, the more reliable the PT and the more reliable the assigned value is. And that sample from a PT with many participants can almost be considered to be a reference material. But for some tests, some matrices, there are not those good PTs. So what to do? Best would be to use a reference material, but for those cases with where there is no PT, there's usually also no reference material. So, but still, I think it would be better to try and cooperate with some laboratories, maybe in the same country, doing the same test, and organize a small PT, because also from a small PT, even if it is not as good as a large PT, it would also usually be not done by a professional PT organizer. The participants still may learn something from it, because that's the main goal. Learn why the results are so very deviated, for example, and which laboratory may have the best result, the one with the high result, the one with the low result. It's a learning process, and that learning process still can work also with a small number of laboratories. There is no other choice. You have to do something.
Okay, my next question, I think you have already answered me, but I would like to have your comments about that. You have been involved in proficiency testing for many years, and what a lab should do in case there is no PT. You encourage them, based on your answer, I realized that you encourage them to try to organize their own small interlaboratory or small PT as far as they can. And from the other side, there is an accreditation body. How accreditation bodies should assess such interlab comparisons, and how should they react to poor performance in such cases?
The accreditation body can only ask to show the effort you make. It's always the same in each case. When something is wrong, you have to prove to the accreditation body that you tried your best available. That's with PT, but also in other cases. There are also a limited number of reference materials. So the accreditation body can demand that you use a reference material, but when there is no reference material, it's a silly question from the accreditation body. But you have to prove that you searched for a reference material. With PTs also, you have to prove to the accreditation body that you searched for a good PT, and when not, that you approached some other laboratories and suggested to start a PT between the small group. But of course, the accreditation body has always the right to say, this is too little to be accredited. I will not accredit the test, because there is too little proof that the laboratory can do this test with a good capability. Yes?
Okay, thank you. One more comment from me. Recently, we had an assessment in an Iranian petrochemical company, and the assessor from the accreditation body noted a nonconformity for the laboratory. The laboratory organized its own interlaboratory comparison in the field of gas testing, because you know that there are very few PTs in that area. There are not so many PTs, and the laboratory couldn't find any PT. And they organized a small interlaboratory comparison between 5 labs. And the nonconformity that was raised by the assessor was that you evaluated the results, the laboratory, you evaluated the results of your own performance, and it is not acceptable for me. The evaluation of the performance should be done by an independent organization, even in case of interlaboratory comparisons. Do you agree with such a judgments, or no, they are in a position to, because there is no PT available, they are in a position to evaluate their own performance.
No, I don't think that is that is not incorrect what the laboratory did. I think the author is too strict. But the organizer of that PT, the laboratory, should be able to show the author all the raw data of the PT. So all the data from the single laboratories that participated, and also how the calculation was done, and also how the conclusions were made. So when all the raw data are available, there is no reason why an independent person should do that. But there should be full transparency. Of course, that's true.
In case there is a full transparency, the independence is not an issue, you mean?
No. Okay.
Because
there are in principle simple calculations, and also the author can check those calculations. So.
My last question is about class 77 of ISO 17025, in which it says that the laboratory needs to participate in PTs if they are available and appropriate. And I would like to have your interpretation of these two expressions. What is available and what is appropriate in terms of proficiency testing?
Well, appropriate is most simple. That is when there is a PT with the analyte matrix combination that is all equal or similar to the one of the test that the laboratory performs. So the analyte should be the same or very approximately the same, and the matrix. That's appropriate. And perhaps also the concentration level. When a laboratory is doing a test in ppm level and there is a PT in percentage level, then that's not appropriate. Yeah? Available is difficult, more difficult, because it not only means that there is a PT, the PT should also be accessible, so open for participants like your laboratory. It should be usable in terms of price, custom regulations, and all those things may avoid the laboratory to participate. The laboratory may want to participate, but sometimes it cannot participate. I know there are PTs that cost $5,000–6,000 for one PT. Now, when you have a small laboratory, you can say, well, that's much too much money. I don't earn that much money for this test. And that's not available. You can show the accreditation body the price of the laboratory and the number of tests that you do per year, and they say, well, this is ridiculous. But when you're a large laboratory that do that test, say 100 times per week, yeah, okay, perhaps then that $5,000–6,000 is not so much money. That's different per laboratory.
Okay, thank you very much for your comments. I am finished with my questions, Rob. If there's anything that you would like to add to our discussion, I would be really happy to hear your final words.
No, I hope that it was that I made everything understandable and that it was useful for your work. Okay,
thank you very much for your time. It's been an honor for me to have you here, and I hope to see you very soon. Thank you very much for the time.
It was a pleasure. Have a nice day.
You too. Bye-bye.